Hi everyone. So today we are going to start our second type of factoring method. So let's do a review of GCF. So factor these two. Pause the video. All right, so the GCF of the first one, 4x. So remember, when we do a GCF, identify what's the biggest thing that divides into both. We divide. When we divide, we're left with x plus 2, right? Those x's cancel. And then parentheses, 4x on the outside. And then the next one, our GCF, is 3x to the fourth. Remember, we take the smaller x. When I divide, I'm left with 9x. Whoopsies, that's not right. 3x to the third. 3x to the third minus 8. Parentheses, GCF on the outside. All right. So pause the video, and I want you to multiply these out, distribute. We've done a bunch of these. So when you distribute, you should get x squared plus 5x plus 3x plus 15, which equals x squared plus 8x plus 15. The next one, x squared plus 4x plus 7x plus 28, which equals x squared plus 11x plus 28. So remember, the way I taught this was we do the x first, x times the x plus 5, and then the 3 times the x plus 5. So that's how I taught this. So this one would be x times x minus 3, and then 9 times x minus 3, x squared minus 3x plus 9x minus 27, which gives us x squared plus 6x minus 27. So today what we're going to focus on is, instead of being given a distributing problem like this, I'm going to give you these trinomials, and I'm going to tell you I want you to factor them. So we're going to figure out, how can I go from x squared plus 11x plus 28 backwards and write it as two sets of parentheses multiplying, two binomials. All right, so what is the general form of a trinomial? So all of the problems we're going to be doing today are trinomials, so 3 terms. So ax squared plus bx plus c. And these letters are going to come back to us later. Now, the ones we're going to focus on today, if you look up at our objective, understanding factoring using trinomials, when a equals 1. So that means all the problems we're doing today are going to look like x squared plus bx plus c. So there's no number in front of x squared, and these are the easy ones. Once putting a in front makes it a lot more difficult. Okay, and then remember our definition of factoring. It's writing a polynomial as a product of two other polynomials or reverse distributive property. So we're doing today reverse, double distributing, or FOIL, whatever phrase you use for the two binomials multiplying. That's what we're going to focus on today. Okay. So look at these two problems we did earlier. So we did them on a few problems ago. X squared, x plus 3 times x plus 5, and this is what we got. And then x plus 4 times x plus 7, and we got this. So looking at these problems, where did the 8 and the 11 come from? Well, 5 plus 3 equals 8. We adding the numbers in the binomials. Right? If 3 plus 5 is 8, 4 plus 7 is 11. So those middle numbers always come from adding or combining the numbers together that are in the binomial. As opposed to, where did the 15 and the 28? Where does this 28 come from? Where did that 15 come from? That came from multiplying. The two numbers in the binomial were multiplying. Multiplying the numbers in the binomials. So we're going to use those two facts so that we can go backwards. So we're going to be thinking to ourselves, okay, if I'm given this, x squared plus 11x plus 28, and I want to factor it, I'm looking for two numbers that multiply to 28 and combine or add to 11. Right? So that's what we're going to constantly be asking ourselves. All right, so let's look at this first problem. So because this is the form x squared plus bx plus c, I know that this is going to factor like this. It's two binomials. So x times x is x squared. So now using what we just talked about, we're looking for two numbers that multiply to 20. Right? That number is what we multiply to, and combine. That was written really poorly. I'm going to fix this. I'm just going to write multiply 20 and combine. I usually use combine because sometimes we're subtracting to 9, right? So what we're going to do, now you might be able to think of these two numbers really quickly. If you can, that's awesome. Not everyone can. So what I'm going to do is we're going to make this little chart. We're going to write down every pair of numbers that multiplies to 20. So we always start with 1. 1 times 20. Then I move up to 2. 2 times 10. How about 3? 3 doesn't work. 3 doesn't go into 20. 4. 4 times 5. And then 5 is next, but we already have 5, so we're done. Then we're just going to add those numbers across. So 1 plus 20 is 21. 2 plus 10 is 12. 4 plus 5 is 9. So we're looking for the pair that combines to 9. So this 4 and 5 are our answers. Those are the numbers that go in the parentheses. X plus 4, x plus 5. And that's it. Now, could you have done that a little faster? Could you just think of the answer? Sure, but sometimes not everyone can do that. They get stuck, they can't think of the number, so making that table is really helpful. All right, so remember, what are we multiplying to? We are multiplying to 28, the number that's by itself. We are combining to 16. So take a pause the video and write down everything that multiplies to 28. 1 times 28. 2 times 14. 3 doesn't work. 4 times 7. 5 doesn't work, and 6 doesn't work. Which pair adds to 16? Well, we get 29 for the top, 16, and 11. So we wanted the 16. So the two numbers that we got there were 2 and 14. So that tells me my answer is x plus 2 times x plus 14. Pause the video and try these two on your own. All right, so we are multiplying to 60, combining to 7. I said 60, it's 6. The next one is 60. I had it in my head. All right, so what are the numbers that multiply to 6? 1 times 6 and 2 times 3. So this one probably you could have thought of in your head. It's got to be the 1 and 6. X plus 1 times x plus 6. Number 6 is a harder one. We are multiplying to 60 and combining to 23. And 60 has a lot of factors. 1 times 60, 2 times 30, 3 times 20. And if you notice, 3 and 20, 3 plus 20 is 23. So I know I'm done. But just so that we have them, it's good practice. 4 times 15, 5 times 12, and 6 times 10. Because these come up, 60 is used a lot because it has so many pairs. So just like maybe take a look at those two. They're not ones that are common for us to use. So pay attention to those. 4 and 15, 5 and 12 are 60. We don't necessarily think of those immediately when we're thinking of factors. So, but it was 3 and 20. X plus 3 and x plus 20. All right, so now we're getting to two that are a little different. We are multiplying to 18, and we are combining to negative 11. So this one's a little different. So we have our numbers that multiply to 18. 1 times 18, 2 times 9, and 3 times 6. We have a problem, though, because when we add across, I get 11. I need negative 11. How do I get that 11 to be negative? I just magically turn it negative? So what numbers add up to negative 11? In this case, we need two numbers that multiply to 18. Negative 2 times negative 9 is a positive. Remember, a negative times a negative equals a positive. So whenever you have a plus at the end and a minus in the middle, it's always x minus x minus. So that's something you really want to pay attention to. And it's still 2 and 9. Because negative 2 plus negative 9 is negative 11. Right? So same idea for number 8. We know our two numbers are going to be minus. So x minus x minus. So we're multiplying to 50 and combining to negative 15. So 1 times 50, 2 times 25, 3, 4, 5, and 10. And that's it. 50 feels like it should have way more, but it doesn't. So the 5 and 10 give us 15, but remember we need them both to be negative. A negative times a negative is a positive. A negative plus a negative is a negative. So it's x minus 5, x minus 10. All right. And this is the last type. So this type is where we're multiplying to a negative number. So we are multiplying to negative 24, and I usually just write m and c, and we're combining to negative 2. So let's write down everything that multiplies to negative 24. 1 times 24, 2 times 12, 3 times 8, and 4 times 6. But do these actually multiply to negative 24? They do not. So what do we need? We need one of our numbers to be negative. Now here's the question. Should we make the smaller number negative or the bigger? If we're combining to a negative, that means the bigger number is negative. Think of it this way. If I have like 8 plus negative 5, that's a positive 3. Negative 8 plus 5 is negative 3. When you're adding numbers with different signs, the bigger one will tell you the sign. So since this is negative 2, we know the bigger number needs to be negative. So now I'm going to add across. 1 and negative 24 is negative 23. 2 and negative 12 is negative 10. 3 and negative 8 is negative 5. 4 and negative 6 is negative 2. So there's my negative 2. So my two numbers are 4 and negative 6. So x positive 4, x negative 6. All right. Same idea. Here's the tricky part, though. What are we combining to? A lot of kids say, oh, I'm combining to negative x. How can two numbers add up to x? That's not possible. So, what's the coefficient of x? What's that invisible number in front of x? It's negative 1. So again, writing down everything that multiplies to 30. 2 times 15, 3 times 10, 4 doesn't work, 5 times 6. Since we're combining to a negative, our bigger number is negative. Combine across, 1 and negative 30, negative 29, negative 13, negative 7, negative 1. So it's 5 and negative 6. X plus 5, x minus 6. All right, same exact thing, but notice the middle term is now positive. Why don't you pause the video and try these two on your own? 11's pretty easy because negative 22 doesn't have a lot of numbers. 1 times 22 and 2 times 11. Now, since we're multiplying to a negative, one of them's negative, the bigger number is positive. The combined is positive, so the bigger number is positive. So it's negative 2 and 11. X minus 2. X plus 11. All right, number 12, multiplying to negative 48. Combining to 2. 48's got a good amount of factors. 2 times 24. So if you're struggling with this, grab your calculator and just start dividing. 48 divided by 1, 48 divided by 2, 48 divided by 3, 48 divided by 4, 48 divided by 5 is a decimal, 48 divided by 6, 48 divided by 7 is a decimal, and then you're back to 8. So now since we're combining to a positive, our smaller numbers are negative. So which pair combines to 2? X minus 6 and x plus 8. And we are finished. All right, last slide. There are 4 problems here. I want you to pause the video and do these on your own. So we are multiplying to 2, combining to 3. The only thing that multiplies to 2 is 1 and 2. So that's a pretty easy one. X plus 1, x plus 2. Number 15, we are multiplying to 24 and combining to negative 10. Now this one's a little tricky. So a lot of kids tell me it's 2 and 12. Here's the problem. What do the signs have to be? For us to multiply to a positive, combine to a negative, do those add up to negative 10? No, they add up to negative 14. So the answer is actually 4 and 6. So be really careful with the signs. Because they're both positive, they're both negative, you add. We are adding to 10, not subtracting to 10. So the answer is x minus 4 and x minus 6. Number 14 has a similar issue where kids get it wrong a lot. So what multiplies to negative 6 combines to negative 5? 1 and 6 and 2 and 3. So which one is it? A lot of kids tell me it's the 2 and the 3, but since we're multiplying to a negative, we need a negative number. So this gives us negative 5. This gives us negative 1. A lot of kids say, oh, 2 plus 3 is 5, but we're subtracting because of the signs. So pay attention to your signs. All right, last problem. This one's probably the most obvious of all of them on this page. Well, maybe number 13 was easier. What multiplies to negative 70 and combines to 3? 7 times 10. So x minus 7, x plus 10. And that's it. That is our second factoring method. So work on your homework. Have a fabulous day, guys.